So today we are going to go ahead and begin section 9.2. And it is the section that's in the textbook, but I'm going to be honest, you're not going to need your textbook for the next couple of days because we're going to pretty much do everything in notes and worksheets for the next few days. Alright, so don't worry about doing it on Friday or Tuesday. I'll let you know next week when you are going to need this, okay? I'm going to be pretty blunt. This is not an easy section to teach, which is why we spend a total of 5 days teaching this. Okay, if you actually think about any sections that we've spent 5 days teaching this year, the answer is 0 of them. Now, we have talked about topics for more than 5 days, don't get me wrong with that, but we've never spent one section this long as what we're going to do here, okay? Because this is not easy. Now, a couple things that I'm going to preface this with. Number one, I know there are some calculators that if you know how to manipulate them will get you the answer that you need for each and every single one of these problems. I'm going to tell you up front right now, if I do not see work on homework, you're not receiving credit for it. Answers are not going to be okay. And if you do not show work on your checks, you're not going to receive credit for even correct answers. Okay? The process is much more important than the right answer. Okay? Now, I will also be honest with this. When I was junior high-ish age, I skipped a math class. And I never learned how to do this. Okay? So when I took my Algebra 1 course, I believe I was a 7th grader. Okay? And I skipped 7th and 8th grade math so I could take that as a 7th grader. And unfortunately, when you get accelerated in math, they don't fill in the gaps. They're just like, these kids will do fine. Right? Which is not the way I found out later that you should accelerate students. If you're accelerating students, it should be because you're doing twice as much material in half as much time. That's how you become accelerated. But skipping math just to accelerate yourself in math is not a good thing. Because what I found out was I had gaps. Gaps that my next teacher would assume weren't there. Okay, and so that became an issue. So I still remember the first time this came up in both my Algebra 1 and my Geometry course, and I was completely lost. Okay? And they didn't teach me how to do it because I was supposedly taught how to do it, but I never was. Alright? And so I became really good at mashing buttons on my calculator and figuring out the answer in a roundabout way. And then finally, one day, my geometry teacher pulled me aside and was like, "You don't know how to simplify radicals, do you?" "No, I don't. I've never been taught that." And so he sat down and he taught it to me, and I picked it up pretty fast, but it saved me an immense amount of time. And part of this was this, because I knew how to manipulate my calculator, I had started to find the answers in a backwards fashion. I could find the answer, and then I could go back through and supply the work that got me to that answer. And I'll be honest, if you can do that, you really have an understanding of it, but it's much easier if you learn it from the top down rather than working from the bottom up. Does that make sense? Okay, so we're working from the top down today. And each day, for the first 4 days as we do this, we're going to add an extra layer on how to simplify radicals. But I'm going to tell you right now, the one I'm teaching today is going to come back for the next 4 days. It's not like we're going to teach this today, and then tomorrow teach a completely different concept. It's all going to boil back to today, which is simplifying radicals that only have constants. So if you look at our notes, again, here's kind of a weird thing that's I don't pay a whole lot of attention to this. I couldn't fit this on a front-back piece of paper. This is a front-back and a front piece of paper because there's that many different examples that we need to take a look at. So today, we are only going to look at the very first page where there are exactly numbers inside the radical and nothing else. Tomorrow, not to get too far ahead, we start to throw in numbers that have variables with them. And then the third day, we start to look at multiplication problems. And the fourth day, we start to look at division problems. But every one of those problems is going to require you to be able to do what we're going to teach you today. Elaine, question. Yesterday, technically, was a new unit. So yesterday we introduced you to the idea of square roots, and we taught that and we explained it. What's that? No. So like what we taught yesterday was the introduction to what you're going to learn today, and today is what you're going to now be testing for your first standard. Yes. So the stuff that we did yesterday, which was all calculator work for the most part, right? Besides order operations, that's not going to be tested, but like you need to know what a square root is in order to be able to do what we're doing today. That's why we started with that. So, all right. So there are 4 basic rules that are required. Oh yeah, back to the whole idea. Like when I learned it, here's what I'm going to tell you. When you get to Algebra 1 next year, your Algebra 1 teacher is going to expect you to know this. I think they take about what we do in a week and they scrunch it down to a day. And it's like, hey, here's real hardcore. Review what you did last year. And then we do 1 extra day where we teach something new that we don't teach you. Okay? And then in geometry, nope. You just need to know how to do it. Okay? So again, it's going to build on and get a little more complex each year. Okay? So there's 4 things that we're going to worry about. All right? We're specifically going to focus on 1 of these today. But by the end of the week, these 4 things all need to happen. Okay? So number 1, there can only be 1 radical. Remember, a radical is a symbol that has a radical symbol in it. A square root is a radical symbol. Okay? There can only be 1 radical sign in your answer. Today, that's already okay. Like, that's been fixed for you. But if you flip to the back page of your notes, you're going to see that that's not always the case. Because on page 3 in your notes, there's 2 radical symbols. So I don't want to get too far ahead, but at the same time, like I want you to understand what I'm talking about here. Okay, so like if you look at the 3rd page of the notes, E and F, you start seeing that there are 2 radicals in your answer. That's not going to be a lie. Okay? Number 2, this is the one we're going to focus on today. No factors of the expression under this radical sign have any perfect square factors other than 1. That is a mouthful. But ladies and gentlemen, this is pretty much when we say simplify the radical, that's what we're talking about. Now, I'm going to piggyback this on something you already know how to do. How did you simplify a fraction? Right, you reduced it, and how did you reduce it? You found a common factor and you reduced it, right? So when if I were to write out in words how to simplify a fraction is simplified when the numerator and denominator have a greatest common factor of 1. Because that's how we defined it. And even to this day, that might not make a whole lot of sense to you. It sounds complex, but really, that's how you reduce a fraction. So, this might not make any sense to you right now, but I would like people, when they're done, to come back and go, okay, now that makes sense. Okay, so this might not be user-friendly now. My hope is that it will be here in a couple minutes. All right, and then number 3 and number 4, those have to do with fractions inside of the radical and also outside of the radical. We're saving that stuff for day 4. So I'm not going to worry about rule number 3 or 4 or even rule number 1 yet. We are going to, for the next 2 days, today and tomorrow, we're going to focus on rule number 2. There are no factors of the expression under the radical sign have any perfect square factors other than 1. Okay. Now, in order to simplify a radical, there are 2 key properties that you need to know. And the first one today is right here. It's called the product property. And the product property says that if I have the square root of a times b, okay, this is equal to the square root of a times the square root of b. Now here's what I want to point out to you. This literally is changing the order of operations, and it's telling you that you get the same answer. Okay? When you look at this problem right here, what's happening first in this? You're multiplying before you square root. Whereas if you look at the other side of it, what are you doing first? You're square rooting before you multiply. Okay? And as we looked at during 3rd period, like order of operations with radicals is rather important. This property allows us to flip that order any way that we would like. Okay? Delaney, question? example of what I mean by this. Okay, and I'm going to pick out some nice numbers that we already know how to do, okay? So, I hope that everyone agrees that the square root of 16 can just be written as the square root of 4 times 4, correct? Alright, according to our property, if we have the square root of 4 times 4, we should be able to break that into the square root of 4 times the square root of 4. Everyone agree with that? That's what the property is allowing us to do. Now, what is the square root of 4? It's 2 times, what's another square root of 4? It's also 2, and 2 times 2 is 4. Well, ladies and gentlemen, what is the square root of 16? It's 4. So you're able to square root these numbers by breaking them up in different ways if you'd like. Okay? So this is probably the easiest way because we know what the square root of 16 is, right? And we also can see that you can break 16 down this way. So this really works for any set of numbers that you'd like to do. Okay? I'll do one that doesn't turn out nice. Everybody's got their calculators handy, so we're going to try this. Okay? I would like you to type into your calculator the square root of 27. Alright, and let's go ahead and round this to the nearest tenth. We talked about rounding yesterday. So if I square root 27, what's that give me? 5.2. Alright, now, here's what I want you to do on your calculator. What is a way to break 27 up as a multiplication problem? 9 and 3. So here's what I'd like you to do. I want you to type this into your calculator. Take the square root of 9 and multiply that by the square root of 3. And when you round your decimal out, what do you get? You should get the same thing. If you're not getting the same thing, then you type something in wrong. Okay? So I'll show it real quick here on my calculator. I mean, this mathematically should be the exact same answer. So, if I, on my calculator here, type in the square root of 27, I get this 5.196. That's where you guys told me to round it and make it 5.2. That's perfect. If I were to take the square root of 9, please notice that I need to end my parentheses here, and then multiply that by a square root of 3, and I end my parentheses there, and I hit enter, then I'm getting the exact same decimal out. So this works whether my numbers are perfect square numbers, which is the example that I showed up there on the board, or if they're just random integer numbers that give me decimal values as I go through it. Okay, again, this works with any number that you can do. You take a number and you break it up into a multiplication problem. Yep. So here's another quick example. If I were to take the square root of 20, okay, I get 4.5. I'm going to show you that this, I actually like this example because you can do this a couple different ways. What if I took the square root of 2 and multiplied it by the square root of 10? You notice that I get the exact same decimal, don't I? And if I took the square root of 4 and multiply that by the square root of 5, I'm going to get the exact same decimal again. Why am I getting the same answer? Because all of these numbers, when I multiply them together, give me what? They all give me 20. So how you want to break your number up really is up to you. So like if I said break out or figure out a way to find the square root of 36, you can do the square root of 36, which of course we all know is what? 6. But here's kind of the cool part, not that we probably ever want to do this, but if you took the square root of 2, and you multiplied it by the square root of 18, you also get 6. And if you took the square root of 3, and multiplied that by the square root of 12, you also get 6. And if you took the square root of 4, and multiply that by the square root of 9, you also get 6. And if you took the square root of 6 and multiplied by the square root of 6, you still get 6. These are all ways that multiply to give you the same number because the products here are all equal to the same thing. Or you could get really crazy and you could do the square root of 3.6 times the square root of 10. Look at that, it still gives me 6. Why? Because 3.6 times 10 is 36. And so it's just different ways of square rooting the same number. Does that make sense? I want us to understand what the property we're using.
Does anybody need their calculator set for
I believe I changed them all yesterday after, unless somebody flipped them back.
or if we had a
Yes. Okay. Alright, so what are we going to do here? We are asking you to simplify this expression. Now, I just got done telling you that you can break numbers up in any way that you'd like to, and you're still going to get the same answer. But when it comes to simplifying radicals, it's almost like simplifying fractions. There's only one right answer. So you might say, well, how, if I can do all these different ways, how can I guarantee that I'm going to end up with the same answer as everyone else? Okay? And here's the thing. You're not just trying to break numbers into factors. Okay, go back up and reread number 2. What type of factors are we looking for? Perfect square factors. So we're not worried about other than 1. So what are our perfect squares? 1, nope, 2 is not a perfect square. 1, 4, 9, 16, 25, 36. Where are we getting that list from, ladies and gentlemen? Our notes yesterday, which is why I told you to have that out, right? So if you don't know your perfect squares list, then you need to have 9.1 notes out, because we have the first 12 perfect squares written out there. So if you need to undo it from your 3-ring binder so you're not flipping back and forth, that's what you need to be able to do. Okay? So we're looking for no perfect square factors other than 1. Because if you divide something by 1, did you actually change its value? No. So dividing something by 1, just like reducing a fraction by 1, it doesn't do you any good. So you're looking for a common factor, a factor that's a perfect square factor other than 1. One of the factors that you've got to find have to be on your list. So, here's the thing. We're going to take a look at the square root of 12. Now, 12 can be broken down into 1 and 12, 2 and 6, and 3 and 4, right? There's 3 different ways that I can rewrite 12. Which one of those 3 ways am I the most interested in? Nope, not 2 and 6. I want 3 and 4. Why? Because what do you notice about 4? It is a perfect square. So you always are trying to find a perfect square number. We just got done talking about those, and what did I tell you? Yesterday you're going to want to have those memorized, right? So you're not always dependent on this paper. So we're going to break 12 into 3 and 4. Now when I do it, I'm going to put the 4 first. And you might ask why, and you'll see why here in a little bit. Okay? I'm going to put my 4 first, and then I'm going to put my other factor here 3 second. Now I hope that we don't have to do it. I've already tried to show you. We all agree that this is the same answer though, right? I just did it like 7 times with the square root of 36. Breaking the square root of 12 into the square root of 4 and the square root of 3 means I'm going to get the same answer when I get done. Everyone agree with that? Okay. Now, why did we pull out a perfect square and why did we put that first? Because you're able to do one of those 2 problems without a calculator now. What's the square root of 12? Or sorry, the square root of 4? It is 2. Do I put a square root symbol back over it? Nope, because you've already done it. It's kind of like the absolute value symbols, right? Once you've done it, you get rid of them. Once you do this, then you get rid of it. Now, here's my next question. Do you know off the top of your head what the square root of 3 is? No. Okay, why not? Because it's not a perfect square. Does it contain any perfect square factors? Meaning, is there any number other than 1 that divides 3? No, because 3 is only divisible by 1 and 3, and is 3 a perfect square? No. So, that means that I can't reduce that any farther. And ladies and gentlemen, that is your final answer. If you still don't believe me, which I hope that you do at this point in time, if you take the square root of 12 on your calculator, and you get this decimal, and then you type in 2 square roots of 3 on your calculator, you're going to notice that you get the exact same decimal. It's kind of like a fraction. We haven't changed its value, have we? You've only changed how it's looked. So you took the square root of 12 and you made it 2 square roots of 3. Now I know what some of you are saying. That's not simpler, that's more complex. This is simpler. For what you're going to be doing this year, next year, the following year, and the year after, this is simpler. Okay? Alright. So now, the square root of, oh yeah, here's my last little thing. Here's why I always put my perfect square part first. Because when you square root that, that always goes out in front. So I could have done the square root of 3 and the square root of 4, but I like people to be able to see that this turned into this, and this just stayed the same. Okay? Alright, now the square root of 20. 20 can go into 1 and 20, it can go into 2 and 10, it can go into 4 and 5. Those are all my factors of it. Out of those 3 sets that I just listed though, which one are you the most interested in? 4 and 5. Why? Because 4 is a perfect square. So where am I going to put the 4 in this problem when I break it apart? I'm going to put it on the left, and behind it I'm going to put 5. Again, those two numbers had better multiply to give me 20. And if they don't, I did something wrong. Now, again, we square root what we can and we try to deal with what is left over. So what is the square root of 4? Again, it's just 2. And that 2 goes outside the radical because, again, once you've done it once, you don't need to do it again. Now, the square root of 5. Do you know what the square root of 5 is off the top of your head? No, I don't either. It's not 2.5 because we're not taking half of it. We're taking the square root of it. Okay? Is 5, so 5 is not a perfect square. Does it contain any factors that are perfect squares? No, because 5 is only divisible by 1 and 5. And we already said we don't worry about 1. 5 is not a perfect square, so here is my final answer. And again, if you type in the square root of 20 on your calculator, and you type in 2 times the square root of 5 on your calculator, you should see that you get the exact same decimal answer. Now, in problems like A and B, there's only one way to arrive at your final answer. In problems like C and D, there are multiple ways. It's kind of like reducing fractions. What's the fastest way to reduce a fraction? Find not just any common factor, but find the greatest common factor. If I find the bigger the number I find, the less work I had to do, right? But was that always what we had to do? No, you could find smaller ones and you could keep going. The same thing works here. 848 is divisible by more than one of your perfect squares. The larger the one you use, the less work you have to show. Okay? But we're going to do C in both ways so we can see this. Okay? So again, you know your perfect square list. 1, 4, 9, 16, 25, 36, so on and so forth. We're not going to worry about breaking it into 1 because we said that doesn't help us. So my next perfect square is 4. Does 4 divide 48? You guys all have calculators. I'm not asking rhetorical questions here. Yes. So that means that I should be able to take 48 and break it into the square root of 4. Now what's the other number that multiplies with 4 to give you 48? 12. Okay. Now, let's go ahead and start doing what we can do here. What do we know the square root of 4 is? It, again, is 2. And remember that once you've done that operation, then you've gotten rid of that square root sign. Now here's where you need to be careful. Is 12 a perfect square? No. Does it contain any perfect square factors? Yes. because 12 is divisible by 4. And 4 is a perfect square. So you actually have to break this. We just did it here, right? You got to break 12 up into 4 and 3 again, don't you? Yes, Mr. Tompkins, you do. Good. I'm glad that we've got some reciprocation happening today. All right, so my 2 that's in front here stays as a 2. What is the square root of 4? It is also, so we got another 2 that's out in front here. All right, is 3 a perfect square? Does it contain any perfect square factors? Nope, so then that's going to stay inside the square root. And to wrap up, what we need to do is this. Any numbers that are in front of the radical get multiplied together. 2 times 2 is? This final answer should be 4 square roots of 3. That's my final answer. Now, I'm going to show you a different way. We already said we don't worry about 1. We already did the 4. Does 9 divide 48? Again, use your calculators. The more you know this, the better off it is. I'm going to be honest. If you are a bystander in this problem for the next 4 days, you're not going to learn a whole lot of this. You need to be typing stuff into your calculator. Does 9 divide 48? No. What's my next one? After 9 is? No. 16. Does 16 divide 48? Yes. So that means that another way to do this problem is to make it the square root of 16. Now, 16 times what is 48? 3. So I've got the square root of 16 and the square root of 3 in this problem, don't I? Now, what is the square root of 16? It's 4. Okay, is 3 a perfect square? No. Does it contain any perfect square factors? Then that can't be reduced. And what's my final answer? 4 times the square root of 3, which you'll notice is the same answer that we got over here. As I talked about, just like reducing fractions. The final answer, there's only one of them. How you get to that final answer, that is up to you. Okay? This one. Off the top of my head, we have 1, 2, 3 different ways that I know that this could be simplified. And you're going to need to show your work in whichever method that you use. Okay? So, I don't care if you guess and check from the bottom up or from the top down. I need somebody to raise your hand, don't blurt it out, and give me a perfect square that divides 180. So, yeah, 12 though is not a perfect square. Remember, your perfect squares are 1, 4, 9, 16, 25, 36, 49, and so on. Delaney, is that a question or a statement?
I didn't go over the statement.
Well, the fact that you don't know means it's a question. You better check that on your calculator. 36. 36 is one of the numbers that's on my list that divides 180. On along with 36, what's my other number? 5. Because 36 times 5 is equal to 180. Alright, now we can do what we do. What's the square root of 36? It is 6. Okay? Is 5 a perfect square? No. Does it contain any factors that are perfect squares? No. So this is going to simply be 6 square roots of 5. Now I'm going to show you alternate methods, because you're not always going to pick the exact same one as everyone else. I need someone else to raise your hand and give me a number other than 36 that also divides 180. 9 does. So you could also break this into the square root of 9. Now, Quentin, 9 times what is 180? $20. Those are how my two factors would break down there. Okay, now, what do we know about the square root of 9? It is 3. Okay, is 20 a perfect square? No. Does it contain any perfect square factors? Yes, it does. What divides 20? 4 does. So we're going to break this into the square root of 4 and the square root of 5 behind that. So the 3 that's in front stays as a 3. The square root of 4 becomes 2. Okay, is 5 a perfect square? Does it contain any perfect square factors? So then that's going to need to stay as the square root of 5. And finally, then we take 3 times 2 to get 6 square roots of 5. Alright, there's another one. Anyone else find another perfect square that divides 180? Cynthia? 4 does. So just Cynthia, if we break it into a 4, what's the other number? 45. Alright, what do we know the square root of 4 is? It is 2. Now, this is where, I'll be honest, you need to start to know your factors of numbers. There is a perfect square that divides 45. Can anyone tell me what it is? It is 9. 9 and what? 9 and 5. So my 2 that's in front stays as a 2. The square root of 9 becomes 3. Is 5 a perfect square? Does it contain any factors that are? No. Multiply together what is in front. We'd have 6 square roots of 5. And Delaney, to answer your question, no, 16 is not. Alright, question.
Why are these perfect Why are these perfect squares?
Because they are the square of an integer.
Well, aren't they all integers? What you're squaring?
Yes, but my answers aren't all numbers.
I know. I'm just saying on our list,
Yeah.
why are only a few of them perfect? Oh, they're just the answers.
They're the results of squaring a number. So we took every number and squared it.
Oh.
But taking every whole number and squaring it doesn't give me every number. It gives me only those certain ones. And we're worried about those certain ones. That's all we're looking for. Alright, I want you guys to try E on your own here. I'm not going to get through all 8 of these today, but I at least want to give you an opportunity to try a couple of these on your own. Do not move to F until Mrs. McClure and I have confirmed E. So as you get to 150, like you could do 2 and 75, and I would agree that that's multiplies to give you 150, but 2 and 75 are not perfect squares. That doesn't do you any good. Remember, you're only looking at that list to confirm what's your perfect squares. Remember, once you square root a number, it's no longer inside of your square root symbol. That has probably been, I've seen most people getting on the right track, but they've kept that in there too long. I will tell you that E and F can only be done one way. G can also only be done one way, but H can be done a couple different ways. Okay, real quickly here, I want to show a couple of these. The square root of 150 is going to break into the square root of 25 and the square root of 6. That is the only perfect square that divides 150. Now, what is the square root of 25? Remember, that does not go back underneath the square root symbol once you've already done it. Is 6 a perfect square? Does it contain any perfect square factors?
No.
So that stays just as it is, the square root of 6. Okay, somebody tell me, how'd you break 18? 9 and 2, the square root of 9 is 3. Is 2 a perfect square? No. Does it contain any perfect square factors? Nope. There's my final answer. Okay, we're going to begin tomorrow by taking a look at G and H. Okay, you do have a homework assignment tonight, which we will get out to you here in just a second. It is a worksheet, and this